Thank you so much for the Cook Prize. Thanks to everyone at Bang Street, and thank you to all the kids who read the book and voted for it. It makes it so special to know that you chose your place in the universe to receive this prize. This book began a long time ago, and it actually began as a completely different story. Originally, I wanted to tell the story of our solar system, of where it came from, and how our planet was born, and eventually how we came to live on it. And I made this book dummy, and I worked really hard on it, but it didn't quite work out. I wasn't happy with it. There was one kind of big problem that I felt that I couldn't figure out how to solve. And that was explaining how big the solar system is, the scale of the solar system and the planets in it. And that was really difficult for me. So I put that one aside and I started thinking about how might I make a book that just explained the scale of the solar system. I started by putting together some ideas for pictures and some ideas for words. So here is one of the first pictures for the book, and here is one of the first drafts. You can see it's not very long. It's really almost an outline of the text. I also did some storyboards. These are called thumbnail drawings. You can see how small they are, about the size of my thumb. They're small sketches, and there's one for each page in the book. I did more than one storyboard. Here's another one. When I was done with the storyboards, when I had some text that I liked, I put it all together into something called a book dummy. Here's the first book dummy for Your Place in the Universe. Notice something different about it? The title, the shape of the book is different. It's a rectangle. And if we open it up, you can see some other things are different too. It starts with a book, not with the kids. But then some things are the same. Here's a boy standing next to a stack of books, and a stack of kids next to a giraffe, a redwood tree, buildings, Mount Everest, and finally, our atmosphere. I shouldn't have said finally. It goes on and on. Here we go to outer space. And it continues to the scale of the universe. Well, I liked some things about that. I liked a lot of things about that. I liked the idea. I liked the stack of books and the stack of kids. But there were some things that I thought I could improve on. Some changes I thought I could make that would make the book better. So I made another book dummy. And here it is. What do you notice? It's a new title. It's a new shape. This one is square. And if I open it up, you can see in the beginning, there's the boy next to a stack of books, but I introduced an ostrich. As I went on, I introduced an elephant and then the giraffe with the stack of kids. We have more different kinds of trees and buildings and Mount Everest. And then when we get to the atmosphere, I decided to try turning the book on its side. Because the atmosphere is so high, I thought it would make it more clear how tall the atmosphere is and how high the International Space Station is. But I wasn't sure if it would work, because turning a book on its side is it's not something that usually happens in a book. So I had to make my book dummy and try it out and try actually turning it to see if I'd like it. Turns out I did, so I kept it, and that's the way it is in the final book. While I was coming up with the ideas for this book, while I was developing the book dummy and writing the first drafts of the text, I was also doing a lot more research. I had learned a lot about the solar system, but this book was going to include buildings and the galaxies and the cosmic web, and there was a lot more that I had to learn. So I read more books. Most of the information that went into Your Place in the Universe came out of someone else's book. So here are some of the books that I read while I was doing research. This one's about the cosmic web. This one is about cosmology. Cosmology is the study of the universe on the largest scales and the origin of the universe. And I like this one. This one had a lot of great photographs and explanations. You can see all of those photographs and illustrations too. And I love books with pictures, so that was a good one for me. I read all sorts of stuff. I was asking lots of questions. You know, when I do research, a lot of times I'll learn something, and that will lead me to wonder something else. And one thing leads to another, and I just keep asking questions and trying to find the answers. That's usually how my research process goes. Now, as I was going along, I was learning a lot of complicated stuff, a lot of stuff that was very new to me about the universe and about astronomy. And I knew that I was going to need some help. So I asked a whole bunch of astronomers for help, and a number of astronomers agreed to help me. But two in particular were really important to my research process. They were Scott Kenyon and Margaret Geller. They both work at Harvard at the Center for Astrophysics. Scott studies planets, and Margaret, she studies galaxies in the largest scale structure of the universe. And do you remember the part in the book about the cosmic web? Well, I found out after she agreed to help me that Margaret was one of the astronomers who discovered the cosmic web. And I'm so grateful for their help. This book wouldn't have been the same without it. Now, when my book dummies were ready, I shared them with my editor, Neal Porter at Holiday House. My editor is the person at the publisher who helps me make the books, and I really need his help, because sometimes I'm making a book and I don't know what to do next, or I think that it's really good, but he finds something that isn't working quite right that I didn't notice. So I worked with Neal, and eventually we worked out all the kinks, and we had a good plan for the book, and then I was ready to go ahead and paint the illustrations. Now, I paint in watercolor. I'm here in my studio right now, and I can reach over here and show you all of my watercolor brushes. Here they are. Got some small ones, like this one. I've got some bigger ones, like here's a bigger one. And I painted this desk right here. I've actually laid out some of the paintings from the book behind me. And now I'm going to show you some slides that show how one painting came together. I paint in watercolor. And the first colors I put down are the lightest colors. I put these light blue washes down. And then slowly I darken the painting and put in more details. So it goes light to dark, big shapes to small shapes, until the painting is done. The last part of this painting were the little white dots for the stars in space. And here it is. So I'll hold it up for you. This is the finished painting. You can see it's on watercolor paper. And you'll notice that there's something different about this painting than what appears in the book. This painting has no orbits on it, has no captions, and it has no text. All of that was added after the fact. I put the orbits in using the computer because I wanted a really precise, accurate line to show where the Hubble telescope was orbiting, or the International Space Station. And then the text is put in after the fact, when the book is printed. The publisher takes care of that. Now this book, of course, it's about where we are in space, where we are in the universe. It's about how special Earth is. It's the only place with life that we know of. But it's also about scale. It's about how big things are in relation to each other. How big kids are compared to giraffes, how big the Earth is compared to the solar system, and how big our galaxy is compared to the whole universe. And I thought that I'd show you a little project that I like that really demonstrates well how big astronomical scales are. But to do this project, we're going to have to go outside. For this project, we're going to make a scale model of the Sun, the Earth, and the Moon. And we're going to use different objects to represent each. For the Sun, we're going to use this exercise ball. This will be our Sun. And for the Earth, we're going to use this chickpea. So here's our Earth, and here's our Sun. The exercise ball represents the Sun. The chickpea represents the Earth. And this peppercorn represents the Moon. In real life, the Sun is more than 860,000 miles across. This exercise ball is 21 inches. At that scale, the Earth would be 3/16 of an inch, about the size of a chickpea. And the Moon would be 3/64 of an inch, about the size of this peppercorn. Now the distance to the Earth is about 107, maybe 108 times the diameter of the Sun. That means that about 107 suns could fit between the Sun and the Earth. This ball is about one of my strides long, which makes it really convenient. Now all I have to do is walk out 107 steps, and I'll know approximately where the Earth's orbit is. I'm going to leave this ball right here on home plate, and then I'll walk out into the outfield. So the Earth, in real life, is 93 million miles away from the Sun. In our scale model, that equals 107 of my strides away from our exercise ball, all the way back there, which represents the Sun. Remember, our chickpea was the Earth, so here that is. And we have the Moon. The Moon is right here, our peppercorn. Now the Moon is about 30 times farther than the Earth, than the diameter of the Earth. So if you had 30 chickpeas lined up, that's where the Moon would be, about 6 inches away, according to what I measured before we came out. So here you can see a scale model of the Moon, or peppercorn, of the Earth, or chickpea, and of the Sun, our exercise ball. Well, I hope you enjoyed that project. Thank you again to everyone at Bank Street. Thanks to all the students who are watching this video and who voted for the book. I'm thrilled to have the Cook Prize for Your Place in the Universe, and I hope you all have a great rest of your day. Bye-bye now.